Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. Hello everybody. Which battery technology costs less? This question is becoming very important nowadays as people are moving towards renewable energy quickly, and many of them are considering to move fully to renewable and to make their CO2 footprint zero. So for that they have to have a battery technology that is costing them very minimum, and they have to have it reliable. For that we have this study, and here we are not considering only the front cost clearly, we are considering all the associated costs that will affect the overall battery or storage cost, and this is referred to in the professional way as the levelized cost of storage. We are discussing that for electrochemical storage and renewable energy applications. We have many of them, as you can see. These are the pictures of some of them, and let's start. For the beginning, we need to have a look at the energy storage classification and market share. We are not going to discuss the pumped hydro storage, which is only available in certain conditions when you can have dams. We are going to discuss only the electrochemical, as we said here, but there is also, for your information, thermal storage, and there is electromechanical. For the electrochemical, as our concern, this is the market share for each of the technologies as per mid-2017. Clearly, lithium ion is abundant at that time, which is almost 60%. But we also have to have a look at the global growth of the electrochemical storage. So as per 1996 up until 2016, this is the growth, and you can consider that from 1996 up until 2007 there is no considerable growth, it's normal growth. But from 2008 up until 2016 the growth is exponential, and even after that. So this is a good chance to consider going for chemical storage and investing even in that sector. To have a good guess, we need to first know what factors determine the overall battery cost or the levelized cost of storage. There is the general main factors like the front installed cost clearly, and the cycles, that is the charge and discharge cycles. If you cycle the battery once a day, so these are the number of days the battery will live, and this will affect, of course, the overall battery cost. The allowed depth of discharge is also affecting the overall battery cost. Are you allowed to discharge all of the available rated capacity, or just 80% of it, or maybe 50% of it? This will, of course, affect the overall battery cost. And the performance degradation, some batteries degrade over time, and this will, of course, affect the overall battery cost. The round trip efficiency, this is the amount of energy that you can get out of the battery compared to the amount of energy you have put in the battery. So the more the efficiency, the lower the overall battery cost, which is better. The maintenance cost, some batteries need to be maintained, and this will increase the overall battery cost. These were the general main factors, but you also have some specific secondary factors that are specific to the application. And this is things like temperature range. In some locations you have temperatures that out of some technologies range, and this will affect the overall battery technology cost. And there is also the charge and discharge rate. Sometimes you need high discharge rate that cannot be accepted by certain technologies, so this will affect the overall battery cost. The safety, clearly, and there is the environmental damage and recyclability. This also will affect the overall battery cost. The end-of-life value, some batteries have end-of-life value that also considerable and can affect the overall battery cost. And there is the usability factor, and sometimes in some designs you are not using the available dischargeable energy from your battery. This will affect the overall battery cost. You need to optimize the usability of the available dischargeable energy. So here, finally, we can have the energy storage unit cost comparison, and that is based on the estimation of only the general factors that we have just mentioned. So this is a graph of the estimated dischargeable energy unit cost for main electrochemical storage technologies, and you can see it goes up from $3 per kilowatt hour up until 0.0016 for supercapacitors, US dollars per kilowatt hour, which is a very good difference between the highest and the lowest costs. And this is because supercapacitors have very high cycling, assumed to be 500,000 or million cycles, and this has become the other technologies after that, like vanadium redox, lithium ion, and so on and so forth. So thank you for watching, and if you have any questions and if you want to communicate with us, please don't hesitate to contact us on Facebook, YouTube. And if you want to have a free software that is Excel based and simple to design your PV solar system, I will leave a link below this video, and I will leave also a link for other videos that will help you understand solar. Thank you for watching again. Assalamu alaikum wa rahmatullahi wa barakatuh.